Okay, so I decided to record the last bit that we did for group bonus points in class so that you know how to do it for the homework. Okay, so I'm going to do these two examples which should help you with the homework of how to approach doing it with a calculator and or doing it by hand. Okay, alright, so first and foremost, of all of these graphs that we have at the end of these notes right here, the only one that you are going to, um, I guess it would be okay at this point to use a calculator for, and it would be absolutely necessary, would be x squared. All of these others, you should be able to do it by hand from Algebra 1 skills. Okay. However, I'm still going to show you how you can use the calculator to help you, but also I'm going to show you how you can use Desmos to help you. So many of you do not have one of these Inspire CX CAS calculator at home. And now they have the version 2. It's like the second model or second generation. Okay? I know that a lot of you don't have these at home. So what I'm going to do with these piecewise functions, again, you should be able to do most of them by hand. A way that you can check them is to go to Desmos and just put them in the graph. Okay, so we're going to do it by hand, and then we're going to check so that you'll know how to do it at home in that respect, so that you're well prepared when you come in class and whatnot. Okay. All right, so let's go ahead and go back to our question or our notes, and we're going to do it by hand. Okay. So remember, all of these are functions. Okay. This is like y equals this. Y equals this. Okay. Otherwise, now that we're in Algebra 2, we're saying y equals this. Y equals this. And we call that y g of x. Okay? Alright, so let's go ahead and graph this function right here. It's a form of mx plus b that you could write it as negative 2x plus 7. And the reason why I'm showing you this is because you learned in Algebra 1 that this is the y-intercept. This is that y equals mx plus b. So if I start at 7, that's where I'm going to have a dot on the y-axis. Now, this negative 2, this negative 2 is going to show us the slope. And we learned this in Algebra 1. That slope is down 2 over 1. So we'll say down 2 over 1, and we'll put a dot. Down 2 over 1, and we put a dot. So on and so forth. So that if we wanted to, we could draw a line that went forever. Let look something like this. Okay, so let me go through those points by shifting this line up, and it looks something close to that. Okay, so if this is my graph, okay, I need to use the skills that we learned last class as far as cropping the picture of that selfie analogy that I gave you. This is the domain piece, otherwise cropping that graph. So we're only going to restrict it to where all x values that are less than 3. So if I were to go to the x-axis and everything that is less than 3 is over here, that's the only place that I actually want to graph and show this blue line that I just graphed. So that's 7 minus 2x. We're going to now restrict it so that basically we're only talking about whenever it is going to be less than 3. Okay, that means it's still going to go to the left forever. So that means it's going to have an arrow way up here on the graph. Okay, and again, because it's open or because it's less than, we know it's not going to include that piece. So we're going to put an open dot right there. This is closed, this is closed, this is closed. All of them are closed except that one at x is equal to 3. Okay? Alright, so that's that piece. Now, the other one is going to look at y is equal to 1. So let me go ahead and highlight that. So y equals 1, or g of x equals 1, is going to be just a horizontal line at y equals 1. So it would look something like this. at y equals 1. But the thing is we're not drawing everything. We're only going to draw the piece that x is greater than or equal to 3. So again, if I were to let's get a horizontal line going here, and we're going to, let's do this one in red, and we're going to do y is equal to 1. And it will shift up here in just a bit. So here's y is equal to 1. But we're only going to do x is greater than or equal to 3. So I'm going to restrict this where x is greater than or equal to 3. So it would start here, and it's going to be colored in because that's where it starts, and it'll go everything to the right. Okay? We just did that part here. Again, that's that analogy of I'm cropping the photo, I'm cropping that selfie, and this is the only piece that I want to show of y equals 1. Okay, now we said this in class that when you look at the domains, one of them will most likely be less than with no equal sign, and the other one touching that same number, which in this case is 3, is going to include that equals. Okay, they both cannot include the equals, because if they both do, it's going to fail the vertical line test, because it's like you're filling in that hole twice and you have two y values for the same input. Okay, so let's go ahead and make sure that our graph is in fact accurate. So we have 7 minus 2x less than 3, and we have y is equal to 1 everywhere where x is greater than or equal to 3. Now, if you wanted to check this, you are definitely welcome to go to either your calculator or Desmos. Let me go ahead and put this calculator so that you can see what I'm talking about. See, the calculator is what's going to be allowed on tests. So I understand that y'all learn Desmos, but the Desmos is not going to be allowed in Algebra 2. Okay? Desmos is a very, very good learning tool for sure, but it's not the calculator or the graphing apparatus that we're going to be using in Algebra 2. So we have to learn how to use this graphing calculator. Okay? Alright, so let's go ahead and put them into the graph and see what we get. Okay, so remember, home to, menu C, OK, OK. So there's two OKs, and that's how we always clear our calculator. We'll do one for new document, one for add a calculator page. We'll press the blue button Control Dock to add a graphing page. Guys, what I've done so far is basically what you're going to do every time you touch this calculator. You're going to set yourself a calculator page, a graphing page, right after you had just cleared it. So if we go back to our equations, we have 7 minus 2x. I can go ahead and put 7 minus 2x, and you'll see the graph, but then I'm going to restrict it only to that domain. Okay? So if I'm restricting it to that domain, let me highlight it, of x is less than 3, that means over here on this graph, I'm going to say where x is less than 3 is only going to exist, let me go ahead and do this in gray, from here to the left. Which is why we're only going to actually graph this piece here on the graph going to the left. And that's exactly the way we did on the actual notes as far as what's lining up with what. Okay? Now, I'm going to go ahead and put, let me erase this so you don't get confused with all this stuff. I'm going to go ahead and put the other function, which was y is equal to 3. Or, let me make sure on that. Y is equal to 1, actually. Okay? So y is equal to 1. Let me go ahead and put in my calculator, I'll press tab, and this is my second function. This is like y2, if you will. So we're going to put 1. And notice this horizontal line at y is equal to 1. But it said we're only going to graph this piece where x is greater than or equal to 3. So if we go over here and we're going to concentrate when x is greater than or equal to 3, let's do this in, let's say, blue. I'm going to say greater than or equal to 3 is where I'm going to actually graph that y equals 1, which is going to be, let me highlight it in green, right here. Okay, that's why we only graphed this piece. So now that you know how to do it with a graphing calculator, you can always go back to Desmos and you can do it and actually restrict it. So 7 minus 2x. Let's go ahead and do this. So we have 7 minus 2x, and you see it's the graph going on forever. Okay, so like if I zoomed out, you see this line would go on forever. But if I wanted to domain restrict this, what I can do is put in the domain in braces. Okay, so let's go to, let me see, it will be with braces. So I'm going to go back to my computer just real quick, and I'm going to show you this domain restriction when it's less than 3. Okay. Alright, so we're going to put in braces. So shift braces, and we're going to say from negative infinity. Okay, so infinity symbol is, forget functions. Infinity symbol is, okay, so to get the infinity symbol, what we're going to do is we're going to just put negative and then just type out infinity, and it will change it to an actual infinity symbol. And then we're going to do less than. So over here on less than, we're going to put x, which is less than 3. And then we'll close the braces by pressing shift and brace. So if you, those bracket symbols on your keyboard, if you press shift, it'll access those braces. Okay, so the other function that we did was y equals 1. So if I put 1, nothing happens. But if I put y equals 1, you have that entire thing shown on that specific interval. So now if I want to say y existed when it was greater than or equal to 3, oops, not there, over here in braces, shift bracket, we're going to put when x's that are greater than or equal to 3. Okay, so we can do it two ways, just like we did in class. We could say it starts at 3, less than or equal to x, and then less than infinity, close the brace, and you see it was only that piece that was drawn. Or you could just say x is greater than or equal to 3, which a lot of you will end up doing. So x is greater than or equal to 3, and it will show the same piece. So Desmos should be a big tool at home that you use so that you can actually see what is my graph going to look like. Now, Desmos should not be used to replace the learning. You need to know how to do this by hand, which is what I did at the very beginning of this video. Okay? So, knowing how to do it by hand, let's get this out of the way. This is what we used with our graphing calculator. But knowing how to do it by hand is what we need to be accountable for on this particular problem. Okay? Alright, so now I've shown you how to do it by hand. I showed you how to do it with the graphing calculator. And I showed you with Desmos, which Desmos is even extra better because it doesn't show everything like the graphing calculator did. You know? So Desmos is a good way for sure to check your answers, not to get your answers. Okay, let's go on to our second example problem. Okay, so the ones that we definitely should be able to do are y equals 4 is going to be a horizontal line at y equals 4, and we would only domain restrict it to 0 to 3. So between x equals 0 and x equals 3, not including these points, we're going to account for everything in between, because that's what this means. It means in between 0 and 3. There are x's that are bigger than 0 and x's that are less than 3. So what I'm going to do is I'm going to go to my graph and crop it. Just like that analogy of the selfie. I'm taking everything off except what I was told would be shown, which is between 0 and 3. Alright, so that one has been done. So that one's good to go. Let's look at our second one. Our second one, let's do this in blue, is x plus 1. That means it's similar to what you learned in Algebra 1, y equals mx plus b, which in this case is x plus 1. That means we will start on the y-axis at y equals 1, and we're going to do a slope of positive 1, because there's an understood positive 1 that exists right here. So let's go ahead and go to the graph. That means by hand I should be able to start at 1 and then go up 1 over 1. Up 1 over 1. Put a point. Up 1 over 1. Put a point. And basically it's this line that would go on forever. However, we only want to show this interval where x's that are greater than or equal to 3. So that means let me go ahead and go to the x-axis. Greater than or equal to 3 means at 3 or to the right. That's what we're going to show on the graph. So all this extra stuff we have to erase, because we only want to show that piece where it starts at 3 and then goes to the right. Now notice, the red graph went all the way to 3 and it was open. However, this blue graph of x plus 1 is going to fill in that gap at x is equal to 3, and it goes on to the right forever. So our graph right now is continuous. These two pieces have been linked together and they are continuous. Okay? Whoops. Let me erase this real quick. Okay. And last but not least, we're going to do x squared. So y equals x squared, and it's going to be on this interval. Everything that is less than or equal to 0. Okay, as far as x. So what does x squared look like? So eventually you're going to learn how to do this by hand, which you can do with a quick table of x squared. And some good points to use are like -2, -1, 0, 1, and 2. And you did a lot of this in Algebra 2, or sorry, Algebra 1. And basically it's saying we're going to plug in this -2 right here and see what we get. So if I were to plug it in, I need to make sure all year that I'm plugging in parentheses. Even though there's no parentheses written there, we're going to see parentheses so that we don't make negative mistakes. So -2 squared is the same as -2 times -2, which is negative times a negative is a positive. If I did -1 squared, it'd be -1 times -1, which would give me 1. 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4. Because again, all we're doing is putting them into this function to see what would that number be if I squared it. Notice they're all positive. Okay, so a quick graph would show this. Let's concentrate at the origin. It would be at, I'm going to do this in purple. It'd be 0, 0. It would be 1, 1. It would be 2, 4. And then you just keep going like 3, 9, and so on and so forth, because you're just taking that input value and squaring it. And then it would be -1, 1, so left 1, up 1. It'd be -2, 4, so left 2, up 4. And it's basically just the mirror image of what you graphed going to the right. Now, make sure that you understand we're only graphing the piece, because these are piecewise functions, where x is less than or equal to, sorry, x is greater than or equal to, let me come back. I don't want to confuse you. We're graphing x squared, which is in purple, where x is less than or equal to 0. I was looking at the wrong interval. So x is less than or equal to 0. So that means where x is 0, filled in and to the left, that's what we're going to graph of the purple function. Okay? So that means all of this extra stuff is going to go away. We're going to erase it because it's not on that interval that we were wanting. Okay? Let me fill that back in as red. And this is our graph. Okay? Notice it passes the vertical line test. If you were to scan this with a, let's put a vertical line, and you were scanning it left to right, that analogy that I used in class as far as that metal detector scanning the graph, right here it would not double beep at x equals 0. It only exists on the purple graph. Over here at x equals 3, it would not double beep because it only exists on the blue function. Because remember, it was open circle on the red. So this is all real numbers is what it's going to be as a domain. It goes to the left forever. There are no gaps. It's not continuous, but the domain would be all real numbers, and it goes to the right forever. Okay? So big things to kind of wrap together on just this graph alone are things like continuity. We know it's not a continuous function, but we know the domain is all real numbers because everything is being accounted for, especially like I said at x is equal to 0. Okay, so now that's how we do it by hand. Okay, we're going to get a lot of practice with this x squared function here real soon. It's called a quadratic function, and you will learn that. But that's how you would do it by hand. If you have an x squared, like on a quiz or test, yes, you can use the calculator, but everything else you should be able to do without a calculator, okay? So let's go to the calculator to see what would x squared look like, okay? So we'll go to the calculator. From here, since we're going to start new problems, what we're going to do is clear the graph. So from here, you can press delete 3 times. So delete, delete, delete. And then you want to say, are you sure you want to delete everything? Yes. So now, pressing tab, you will see if I graphed x squared, and squared is right next to that number 4, it would show this graph here, okay, which we did by hand. But again, the domain restriction was saying everything that was to the left of 0, okay? Remember it said anything that was less than or equal to 0. That means here and to the left. That's why we graphed what you see in purple right there. Okay? So if you were using the graphing calculator, you would go over here and basically think to yourself, all right, I need to essentially erase all of this stuff going to the right. Okay? So I know you can't do this on your paper or whatnot, but it would basically show that purple graph starting here, and I want you to envision that cropping. Again, that cropping of that selfie is what we just did. Okay. So yeah, for the sake of time, I'll just quickly go over to, one more time, over to Desmos, and I will show you how you can input these 3 functions, x squared, 4, and x plus 1, in those domain restrictions. Okay? So let me go ahead and write that so that we can, when we go to Desmos, so x squared, 4, x plus 1, and the restricted domains occur at x is less than or equal to 0, between 0 and 3, not including either one, and then finally x is greater than or equal to 3. Alright, so let's go to Desmos, and I'll say it again. This should not replace the learning, but help you know that, yeah, I got the correct answer when you're at home, if you don't have one of these graphing calculators. Alright, so let me go back to my desk, and we're going to input these 3 functions. Okay? Let me take care of this line. Maybe not. Alright, so let me go back to my desk, and we're going to put in those purple functions. So let's go ahead and put x squared. So x squared that squared button is right here. And we're only going to, so space, shift, bracket to access the braces. And we're going to say x's that are less than or equal to, here's the less than or equal to button, 0. And close the brace. And it's exactly what our graph looked like when we did it by hand. Our second function that we're going to do is y equals 4, space, shift, brace, and we're going to say between 0 is less than x is less than 3, shift, brace to close it. And you notice this graph won't show open holes. They exist there, but it won't actually show you an open hole. Okay? So if you use Desmos, you got to get a little bit, you have to understand as far as these less thans, when they don't include it, that they're actually showing that there is an open hole there, and it looks like you would actually have to write it in. So there's a hole there, and there's a hole there. This is included, and it's to the left. Okay? And then now let's do the last one, the x plus 1, where x is greater than or equal to 3. So we're going to put our third function as x plus 1, space, shift, bracket will give you that brace, and we're going to put x's that are greater than or equal to 3. And that should be our graph. Okay? Greater than or equal to 3. Again, you need to understand what's happening at 3. Okay? You need to understand what's happening at 0. And then you got to see, let's say in this case, the x squared was the green graph. You have to see that it is equal to 0 on the green graph. So it would be colored in. And then you got to see, let's use red. It was equal to 3 on this x plus 1 graph. So you would draw red here of this line going up and to the right. And then the black one in the middle is y is equal to 4. It's open at x is equal to 0. It's open at 3, but still filled in by this third function. And then this would close off. All right. Now I've shown you how to check your work. I've shown you how to do it by hand. And by checking the work, I mean using the graphing calculator and or Desmos. So now you should be able to do the homework very well. That's due next class. Now, I'm going to go to the homework. What I just did for you, you should easily be able to do numbers 1 and 2. So just for extra practice, what I'm going to do on this same video is I'm going to show you how you would write out this number 3 right here on your homework. Okay? Alright, so let's go 150. Actually, I will show this on another video.